So you
वो
answer.
है था।
ठीक है. So let's start from here. This is a researcher notices that atoms of an element are releasing energy. Why are the atoms releasing energy, and when do atoms release energy?
सी।
ठीक है, atoms are radioactive. That's when they release energy. So atoms on their own they never release energy except when they are radioactive.
Assalamu alaikum, sir.
Assalamu alaikum. Question number 6 is the energy profile diagram for the forward direction of a reversible reaction is shown. First thing, is this an endothermic reaction or an exothermic reaction?
सर एक्सो।
ठीक है, this is an exothermic reaction. We did discuss this. When you have, so we did discuss this when we were talking about energy profile diagrams as the first part. In an exothermic reaction, more energy is released than is absorbed during bond breaking. More energy is being released. So the products have a lower energy or a less energy compared to reactants because they have lost energy. And the activation energy is going to be this one, and the delta H would be from the reactants to the products. This is what we did. Now, in this question, he's saying which row correctly describes both the sign of the activation energy and the type of enthalpy change for the reverse reaction. Now, he's talking about the reverse reaction, which means you're at your products and now you have to go back to the reactants. So think of this in the opposite way. ठीक है, इसको उल्टा करके देखो कि what would happen if you go from the products back to the reactants. Uh, what would be the activation? Is it going to be an endothermic reaction or an exothermic reaction if you want to go back?
Endothermic.
The products are at a lower energy, and if you want to go back, you have to reach a higher energy to reach the reactants. So that would mean it's going to be an endothermic reaction. So the enthalpy change would be endothermic. So it's either going to be A or C. And what would be the sign of activation energy, and which point, from which point to which point would be the activation energy if you're going back? Activation energy is from the starting point right to the top. Okay, so it's going to be from the starting point, which is over here. Okay, can you see the Noor arrow nazar aa raha hai? Hassan, arrow nazar aa raha hai?
जी सर जी।
Acha. So the activation energy would be for the reverse reaction. Okay, he's going backwards. Okay, going from this point to this point. So you're going to start at this point and you're going to go all the way to the top. That is the energy that would be needed to break the bonds. It would be needed to break the bonds, and then new bonds would be formed. So you're going back. And activation energy is always positive. It's always positive. It's always endothermic. That's the energy that is needed to start a reaction. So the answer would be C. Okay? Activation energy is always, in any case, whether it's an endothermic reaction or an exothermic reaction, the activation energy is always going up. In an endothermic reaction, you start from the reactants, you go all the way up. In an exothermic reaction, you start with the reactants and you go all the way up. That is the energy that is initially needed to break the old bonds. The next question is the energy profile diagram shows the pathways for a reaction with and without catalyst. Which energy change is the activation energy for the catalyzed reaction? So which curve is the catalyzed one? The higher one or the lower one?
Higher one.
लोअर वन।
Lower one.
Lower one. ठीक है, Noor. Uh, because in a catalyzed reaction, yeah, we did discuss this. ठीक है, the activation energy decreases. Why do reactions not happen? Because they initially need a lot of energy to break the old bonds. So Hamza, enthalpy change किस part का पूछ रहे हो आप?
So the last question.
The previous one or this one?
Sir, before this.
Okay, what's the enthalpy change for this? The enthalpy change is going to be endothermic. Okay, enthalpy change is the net energy change, and he's talking about the reverse reaction. Okay, he's bold में लिखा है. So it's going to be endothermic. You're starting at this point, you're going back. So you're gaining energy, right? Starting at the reactants, going to the products. So you're gaining energy. That's endothermic. Hamza, is this clear?
Yes, sir.
I said, Noor, activation energy में the height decreases. The reaction becomes easier. There's less energy needed to start a reaction. The reaction speeds up. So, so the lower curve, and that's the one with the catalyst. So he's asking which energy changes the activation energy for the catalyzed reaction. It's going to be B. Noor, is this clear? Hamza, is this clear?
Yes, sir.
Yes, sir.
So next is, how does a catalyst speed increase the speed of a reaction? Uh, what it do- what it does is, okay, it lowers the activation energy. It makes it easier to break the old bonds. Okay? Every reaction, the first step is you have to get rid of the old bonds and then you form new bonds. Okay? All the reactions that
Sir?
we have studied, you would first have to break all these old bonds and then you have to form new bonds. So there's energy needed at the start of the reaction to break these old bonds. So if the energy needed at the start is very high, it's very large, then the reaction is not really going to happen at a very fast pace because the reaction would be very, very slow. But if it becomes very easy to actually break these old bonds, then the reaction would happen very, very fast. And that is what the catalyst does. It lowers the activation energy. It lowers the amount of energy that is needed to start a reaction. Okay, is this clear to everyone? Did somebody have a question?
No, sir. I got it.
Next is okay. Next is the combustion of methane is exothermic. The equation is shown below. What can be deduced from the fact that the reaction is exothermic? So the reaction is exothermic. Uh, Going back to this, what happens in an exothermic reaction? In an exothermic reaction, less energy is needed to break the bonds. And when new bonds are formed, more energy is released. It's like burning paper. Initially, at the start, you need a very small amount of energy. You provide that by lighting a match. But then the paper burns and a lot of energy is released. So overall, it's an exothermic reaction. So the reason an exothermic reaction is that the less energy is absorbed during bond breaking, but more energy is being released during bond formation. So if we go back, what can be deduced from the fact that the reaction is exothermic? So less energy is involved in breaking bonds, but more is involved in making bonds. More energy is released during bond formation and less energy is taken in during the breaking of bonds. Is this clear? After is this clear, Hamza? Noor, Hassan, clear?
Yes, sir.
Yes, sir.
So next is there's this reaction nitrogen monoxide is an as a he's given you the reaction, he's given you the enthalpy change, and which diagram represents the energy profile diagram for this reaction? It's an endothermic reaction. It's a plus sign. Okay, which one is is a graph for an endothermic reaction?
A.
But it's either A or B. Endothermic reactants.
Yes, sir.
It's either A or B. Reactants to products. Reactants to products. Energy would be gained. Plus, which one is labeled correctly? That's going to be A. Because activation energy is from the start right to the top. Which is true in both cases. Enthalpy change is from the reactants to the products. So that's A. Not from the products back to the reactants. So it's all I told you every arrow is going to start from the reactants. That's your starting point. So activation energy is from the reactants right to the top, and enthalpy change is from the reactants, which is this side, to the products. So next is question 11. This is again an energy profile diagram, and he's saying that the energy diagram for the reaction between sodium hydroxide and dilute hydrochloric acid is shown. This is the ionic equation. Hydrochloric acid produces H plus ions, NaOH produces OH ions, and they combine to form water. Uh, so it's an exothermic reaction, which means the reactants have more energy and then they lose energy to form the product. What can be deduced from the diagram? The energy change when
C.
one.
Yes, C.
C is correct. The products contain less energy than the reactants because they have lost energy. It's an exothermic reaction. D is obviously incorrect. You can't really tell OH ions or H plus one. I mean, they are the same energy. And A is also incorrect because you're not forming water from hydrogen and oxygen. You're actually forming water from H plus one and OH ions. So A has nothing to do with this question. I mean, it's a completely different reaction. Okay, you're forming water from H plus one and OH ions. They're saying you're forming water from hydrogen and oxygen, which is obviously not true. Okay, Mariam, is this clear?
Yes,
Bakyo?
sir.
As the next is the formation of liquid water from hydrogen and oxygen is thought to occur in three stages. So the three stages given. He's saying which stages would be exothermic. As a bond breaking, is bond breaking exothermic or bond formation exothermic?
One for
Mission.
Okay, remember energy is needed for breaking of bonds, so that's endothermic. So in the first step, what are you doing? Breaking bonds or forming bonds?
Breaking.
breaking.
Okay, you're breaking bonds because you had two hydrogen molecules and now you have four hydrogen atoms. Okay, uh, when there's a four written in front of it, that means there are four completely separate hydrogen atoms. So you're breaking bonds. So this is endothermic, not exothermic. What's happening in stage two?
Bond
It's a
forming.
bond formation.
Okay, this is bond formation. Atoms are joining up and they're forming water molecules. So they're forming bonds. So this two is obviously exothermic. And the answer would be D because it can't be one. So these two are all three are wrong. So it's going to be D. But look at three. Is this exothermic gas to liquid? Do particles lose energy or gain energy when they turn into liquid?
Lose.
Okay, they lose energy. Next one is what is the effect of catalyst on the activation energy and on the enthalpy change of a reaction? On the enthalpy change, nothing happens, unchanged. But activation energy, it decreases. Okay, remember this point as well that when you add a catalyst, किधर add किया था? अच्छा, when you add the catalyst, the difference between the reactants and products remains the same. It's only that the height would be changed. The activation energy would be lesser. Otherwise, the enthalpy change or the overall net energy change of the reaction is going to be exactly the same. Now, next is which process is just थोड़ा बहुत ना you need some ideas about renewable energy, just general knowledge, which is okay. What are sources of renewable energy? That's wind and solar. These are the more common ones. Then there is geothermal as well. I'll just briefly outline some of them over here. Okay, and you pretty much know most of them. Okay, what happens? What happens in? Okay, I'm just going to list some general. I mean, there are lots of renewable energy methods. Okay, one of them is wind. You have obviously solar. Okay, I mean these two are the most popular ones now. Then you have geothermal. Now geothermal is it's usually used to I mean, it's used in a lot of places. What happens is that the earth is warm. So what you do is you lay down pipes deep underground, and when the cold water goes there, it heats up and its temperature changes. So the cold water goes in and warm water comes out. You get a lot of modern homes they actually use this for heating purposes, for heating the water or for even for the radiators, the plates that are in the walls of the house. for warming up the house, and it actually works both ways. In the summer, uh, the earth is relatively cold, and the outside weather is kind of warm. So it automatically switches. So in the summers, in relative terms, the earth is cold, whereas the outside temperature is very hot. So when the water enters, it's going to be warm water, and when it comes out, it's relatively it's relatively cold. Okay, because the temperature of the earth doesn't really change much. The outside temperature, the atmosphere temperature changes a lot, but the earth's temperature doesn't really change a lot. So if it's cold outside, in relative terms, the earth would be relatively hotter, and the water would come in and come out warm in relative terms. And in the summer, it's the opposite. But you can also run power plants on this. If you lay the pipes much deeper, it's going to be uh, uh, a lot of thermal energy can be converted into kinetic energy, and you can run turbines on it. I said that's geothermal. Uh, so these are some of the renewable energy sources. One of them that we did very in a lot of detail. So one of them that we did in a lot of detail was the hydrogen oxygen fuel cell. That was also renewable. TK, we did this in fuel cells, in electrolysis, in electrochemical cells. To remember, that one is also renewable, but it's expensive and it's very difficult to store hydrogen and oxygen gases. So coming back to the worksheet, which process is a renewable energy source? First one, combustion of coal. Is this renewable?
No, sir.
No.
Because you're going to run out of coal after some time. Uh, and you're going to run out of quality
Sir,
coal.
D.
Hmm?
Sir, D.
D is renewable. Some other renewable sources are like photosynthesis. How does photosynthesis help? You can make glucose using photosynthesis, and glucose can be converted into ethanol, alcohols, and you can use it as a fuel for cars. Then obviously photosynthesis makes wood as well, and you simply burn wood to produce energy. That is renewable, not a good option, but that is renewable because you can grow the plants and the trees over and over again. आवाज आ रही है बहीम? बाकियों को आ रही है?
Yes, sir.
ठीक है बहीम, try and rejoin. ठीक है. So coming back to this, electrolysis of aluminum oxide is obviously not an energy source, man. That has nothing to do with energy. Fractional distillation of petroleum. Petroleum is also non-renewable. You're going to run out of petroleum one day. Photosynthesis is you can grow the plants again over and over again. You can uh, and ethanol, making ethanol or alcohols out of sugar. That's one very important renewable energy source. Now, this is a diagram shows steps by which carbon dioxide can be converted into organic products and finally returned to the atmosphere. Which step is endothermic? Which of the steps is endothermic in this case? So what is this step where you convert carbon dioxide to glucose? What is that called?
Photosynthesis.
Okay, that is
Achha,
photosynthesis, and that requires chlorophyll, and that requires sunlight. It absorbs sunlight. It's an endothermic process. Okay, is this clear? A is the option. That's the one that's
yes.
endothermic. So next one is you have a reaction pathway. First thing, endothermic or exothermic? What is this? Reactants,
Exo.
Exo.
they lose energy, okay? So they are, this is exothermic. So it's an exothermic reaction. The sign of enthalpy change would be negative for exothermic reaction. As the next one is the energy profile diagram for the forward direction of a reversible. I think we did this. We've already done this. The burning of hydrogen is an exothermic reaction. Which statement explains this? Uh, so why are reactions exothermic? Because uh, the bonds formed are stronger than those broken, which basically means this thing. Where's the why are reactions exothermic? Because less energy is absorbed during bond breaking, which means that weak bonds must be broken or are being broken, and more energy is being released during bond formation, which means that stronger bonds are formed. So, so overall, the bonds formed are stronger than those broken. So it uses up less energy, but releases more energy. So D is the correct option. Next is uh, what information is correctly describes the effect of the catalyst on the activation energy and enthalpy change. Remember, enthalpy change, no change. Activation energy, it decreases. Okay, the curve has a smaller height. So why is nickel? Forget this. So you're given four reactions. Diagram shows the reaction pathway for a reaction without a catalyst. Which diagram shows the addition of a catalyst which speeds up the reaction? So as a pair of A and B, are A and B the correct ones if you add a catalyst?
No, sir.
No.
Okay. Uh, which one? Wait a second. One picture. It's an exothermic reaction, right? Reactants are higher and products they're lower. So it's going to be C. The height of the curve would be lesser. That's it. Is this clear? Noor clear? Mariam, is this clear?
Yes, sir.
ठीक है Hamza clear है?
Yes, sir.
Yes, sir.
So next is which of the following is an endothermic reaction? Combustion of ethanol. क्या है? Is it endo or exo?
Exo.
No.
The exo. It's very exo. ठीक है Alcohols are used as a source of energy in cars. So the formation of carbohydrate and oxygen from carbon dioxide. What reaction is this?
Photosynthesis.
ठीक है which is absorbing sunlight, which means it's an endothermic reaction. So B is the correct option. So next is, we forget that. We did this as well. In which process is energy released? Electrolysis of water. What is electrolysis? Endo or exo?
Sir, endo.
ठीक है, that is endo because it uses up electrical energy. We did classify it as an endothermic reaction when we were talking about endothermic reactions. Electrolysis was one reaction which was endothermic because it uses up the energy from a battery and you converts that into chemical energy or drives the chemical reaction because of that. So it uses up electrical energy from a battery. So that is endo. So forming a hydrogen molecule from two hydrogen atoms. Is this endo or exo, and why? राफे क्या होगा?
It can be exo.
ठीक है, this is bond formation. Two hydrogen atoms are forming a hydrogen molecule. So two hydrogen atoms joining up to form a hydrogen molecule, that is bond formation. Because hydrogen is H2. So you have a hydrogen atom, another hydrogen atom, and they join up to form an H2 molecule. So that is bond formation, which is going to be exothermic. Next is forming a hydrogen. So that's exothermic. So B is the answer. Photosynthesis is obviously endothermic. Remember, fractional distillation also uses up energy. Why does it use up energy? Because fractional distillation, you have to heat the substance. For example, this is the so fractional distillation can only happen if you heat the substance, and so that means it's taking in energy. It's an endothermic process, and then it's going to evaporate. So where's the questions? So let's skip some questions. Let's talk about this one. The energy profile diagram shows how adding a substance X to a reaction mixture changes the reaction pathway. So with X, the height is lesser. What is X?
Catalyst.
It's a catalyst, because when you added X, the height decreased. Now, which change occurs when X is added to the reaction mixture? So you're adding a catalyst. Nothing happens to the enthalpy change. It doesn't become less exothermic or more exothermic, it just becomes faster. The rate of the reaction would increase because the activation energy is lesser. It's now much easier to start the reaction, a lot easier to break the bonds. So then you have this thing, and he's saying, okay, which option is correct? So read the question. I mean, the curve is in front of you. Read the statements. Which one do you think is the correct one? The activation energy of the reaction is H3 minus H1. Is that correct?
Yes, sir.
Yes.
Because that is correct. Okay, activation energy is from the start, the reactants, right to the top. So that is H3 minus H1. So that's the option A is the correct one. अच्छा फिर let's just hold on 1 second. Achha, so yeah, which fuel produces achha, this one is kind of a moles question. Okay, let's do this. So you're given that the MR is given. He's saying which fuel produces the most energy when 1 gram of the compound is completely burned. So this is energy per mole, minus 880 kilojoules per mole. What is 1 mole? 1 mole is the mass equal to the MR. I mean, what's moles is equal to mass over MR, right? So the mass of 1 mole is basically the MR. So 16 grams of methane is going to produce minus 880 kilojoules of energy. So can anyone calculate how much energy would be produced per gram? He's asking for 1 gram. So what you do is you divide minus 880 by 16. Similarly, 1380 kilojoules of energy is being produced by 46 grams of ethanol. So you're going to divide 1380 by 46 to get the energy for 1 gram.
तो दोबारा बताएंगे एनर्जी कैसे ढूंढ रहा है
As the first one, what he's given you is, let's do over here. So what's given is that they're saying methane. They're saying methane produces minus 880 kilojoules per mole, right? Minus 880 kilojoules per mole. Per mole. What's a mole? Moles is equal to mass divided by MR, right? So the question is asking, okay, find the energy per gram. So I need to find the mass. So what is this amount of energy? It's minus 880 kilojoules per mole, per 1 mole. So moles की जगह what you do is you substitute 1. ठीक है, if you substitute 1, the mass would become equal to the MR. So when they say per mole, yani per 1 mole, what they're talking about is that the mass of the substance would be the MR, which is going to be 16 grams. Okay, 16 grams of methanol is going to produce this much energy. Hassan, did you get this?
सर एक दफा बताएंगे
Let's go further. Let me elaborate this. Minus 880 kilojoules per mole. Okay. What does that mean? It means that minus 880 kilojoules of energy is being produced by 1 mole, right? Hassan, ये clear है? और याद है clear है?
yes
अच्छा तो what is the mass of 1 mole of methane? ठीक है, find the mass of 1 mole of methane. How do you find mass? Mass is moles multiplied by MR, right?
yes sir
So it's going to be 1 mole multiplied by the MR, which is 16 in this case. So the mass comes out to be 16 grams, right?
yes sir.
So that means that minus 880 kilojoules of energy is being produced by how many grams? 16 grams.
16 grams.
So the question had asked per gram, don't know, per gram. So 1 gram would produce how much energy? It would be minus 880 divided by 16, right? Is this clear?
Okay sir. Yes sir.
So instead of doing all this working, what you just need to do is, this is minus 80 divided by 16. For this, it's minus 1380 divided by the MR, which is 46, minus 2200 divided by 44, minus 4800 divided by 100. So for each option, you're going to get the energy that would be released per gram. Is that clear?
Yes, sir.
Okay, Rafa, is this clear? Hamza, did you get this?
Yes, sir.
Okay, so the thing is to find the answer. Which one is the correct option? Okay, which fuel would produce the most energy per gram of the compound?
Methane.
What is the value that you're getting? Minus 880. It's probably methane's. This is 4.8.
सर माइनस का निशान लाएंगे
Hmm?
माइनस के साइन लाएंगे कैलकुलेशन के दौरान
अच्छा, remember one thing. लगाओगे माइनस का साइन लगाओगे. अच्छा, remember one thing. There's plus 100 kilojoules of energy. Okay, there's a minus point. There's plus 100 kilojoules of energy and there's minus 100 kilojoules of energy. Which one is the bigger value?
सर प्लस 100
अच्छा, so remember, don't confuse it with the number line. Like if you have two numbers, 3 and minus 1, then 3 is obviously a bigger number. If you have two numbers, 1 and minus 3, then 1 is the bigger number, right? On the number line. But when it comes to energy, so remember, both of these are exactly the same value. Okay, because the minus and the plus have a completely different meaning here. Minus means the energy is being released, plus means the energy is being taken in. But the quantity of energy is exactly the same. This is also 100 kilojoules, this is also 100 kilojoules. So remember, this is not the math plus minus, it's the direction plus minus. Okay, plus means energy is being absorbed, minus means energy is being released. Okay, is this point clear?
yes
Plus,
sir
okay, so if somebody is going to ask you, okay, there are two numbers. One is minus 30 kilojoules and the other one is plus 15 kilojoules. Which one is the bigger number?
Minus
30
30.
Okay, so remember, it's going to be minus 30 because the minus and plus doesn't really matter. That only shows direction. That just shows. So when they're asking, okay, energy quantity wise, which one is the bigger value? That's 30 kilojoules. The other one is 15. The minus and plus simply represent the direction, whether it's being taken in or whether it's being released. So no need to consider the sign of the energy when you're talking about the quantity of energy. So in this question, first, yeah, I thought Rafael, the first one is the biggest per gram.
Yes, sir. It is 55.
As I said. Next one is which energy changes the activation energy for the catalyzed reaction? What's the correct option?
B.
B, sir.
So the formation of hydrogen iodide reaction is an endothermic process. What can be deduced? Why is it endothermic? Because more energy is being absorbed to break the bonds and less energy is released during bond formation. So I said, remember, it doesn't depend on the number of bonds. The number of bonds don't matter. The quantity of bonds don't matter. As somebody's mic is on. I said the quantity of bonds, they don't matter. It's the strength of the bonds that matters. I mean, you could have very weak bonds and you could have a lot of them, but the energy required would still be lesser. You might have very few bonds, but they would be very, very strong bonds. So the energy required would be a lot. So it's not about the quantity of bonds, it's more about the total amount of energy needed to break the bonds. So the products possess less energy than the reactants. Is that correct or not in an endothermic reaction? No, you're wrong. Okay, in an endothermic reaction, they're releasing energy. The reactants, they release energy to form the products. So the products possess. Okay, that's correct. C is correct. In an endothermic reaction, the products possess less energy because they're losing energy. The reactants are losing energy to form the products. So C is correct. As a Baki, let me just. I said this one. He's saying dissolving ammonium nitrate in water is an endothermic process. What happens? The which graph shows how the temperature alters as the ammonium nitrate is added to water and then the solution is left to stand. Which one is the correct graph? That you're dissolving ammonium nitrate and the process is endothermic and then you leave it to stand. In an endothermic reaction, huh? I said, remember, in an endothermic reaction, the temperature always drops. In an exothermic reaction, heat energy is released and the temperature rises. So the temperature is going to drop. So it's either going to be B or it's going to be C. Okay, the temperature of the water is going to drop. Okay, always remember this. Because when you measure temperature, you're basically measuring the temperature of the surrounding, or not the substance itself. So so the temperature is going to drop. कौन सा होगा सान? कौन सा होगा? Which one, Anur?
C, sir.
Why not B?
Sir, क्योंकि left to stand है शायद.
If it's left to stand, तो water का temperature वापस, what would happen to the temperature of water after some time? Let's after 4 hours. It's going to come back to room temperature. Like if you add ice to water, right? The temperature would initially drop, right? But if you just
Like coming to its normal state.
ठीक है, so it's going to come back to room temperature. वापस room temperature पे आ जाएगा. So it's not going to stay low forever. So if you just leave it to stand, it's going to come back eventually to room temperature. ठीक है, is this clear? Rafi, clear है? Hassan, clear है? Aris, is this clear?
Yes, sir.
Yes, sir.
Yes.
So I think we'll continue with this. We're almost done with this. Most of the questions are simply the same ones. We've done questions like this, okay? Where you had to calculate the bonds broken and the bonds formed, and the energy is already given in the question. So you just have to calculate. We did questions like these, okay? You just have to calculate.
Okay.
Hanji.
एक दफा टेस्ट में क्वेश्चन आया था कि हम लोगों को बॉन्ड एनर्जी ढूंढनी थी।
हाँ, ऑपोजिट भी हो सकता है ना कि आंसर गिवन होगा और
जी सर।
one of the values would be missing. Let's say this is x.
अच्छा
मतलब वही करना है except कि the answer is already known but one of the values is unknown.
ओके सर।
चलो ठीक, I mean most of these are ठीक है, most of these are exactly the same. चलो ठीक है, we're done with this topic. I'll send you the worksheet of metals. I'll send this worksheet as well. Okay then.
सर
जी
सर जो आपने पेपर भेजा है गूगल क्लासरूम में, सर मैं जीसी का कुछ उसी ईयर का पेपर कर लूँ सॉल्व?
मेरे ख्याल से वही हाँ जीसी, तुम जीसी का कर लो, वही वाला
ओके सर।
उसी ईयर का। ठीक है, चलो ठीक है, ओके, टेक केयर,
अल्लाह हाफिज़।
अल्लाह हाफिज़ सर।
अल्लाह हाफिज़। और सारे पेपर वो करना जो मैंने भेजा है। ओके।